Welcome back, everyone, to our subject trigonometry. And in here, we're going to discuss the third topic of trigonometry, and that is the right triangle trigonometry. So, finally, we have topics that really involves more on triangles, not unlike those previous two topics that we discussed, or two previous topics, I mean. So the first subtopic that we're going to discuss is actually a recall lesson or a recap, which is Pythagorean theorem. So you see, in a right triangle, first and foremost, I forgot to add one detail to describe what right triangle is. Oh wait, no. Let me change the color for a moment. So this is supposed to be white. Hold on for a second. It's white. Okay. What? Okay, anyways. So going back, to simply describe or define a right triangle, the right triangle should have an interior angle or one interior angle of 90 degree. Okay? So if you see a right triangle and then uh you have a given angle of this one, then that means it is a right triangle because in a right triangle you should have a 90 degree or 90 degrees angle. Okay? In a right triangle there are three parts. I mean, yeah, there are three parts, but two of them are just the same. Okay? One, which is the longest sides, and the other two are just legs or two sides. Okay? So we can simply represent these two sides as A and this one as B. The longest side shall be represented as C. So what is Pythagorean theorem? I think you already know this formula before. So Pythagorean theorem, basically, it's about having the sum of the square of two sides is equal to the square of the longest sides. Okay? So what's that again? Pythagorean theorem is basically having an equation where the sum of the square of two sides, okay, is the same as the square of the longest side. So that means the formula would be a squared plus b squared is equal to c squared. Okay? We can use different letters here, by the way. Okay? Uh, Commonly, A, B, and C are used here. But there are some other letters that are actually useful. Like, for example, this is your Y, this is your X, and this is your Z. So that means you will have X squared plus Y squared is equal to Z squared. Okay? By the way, if you're going to put letters, be careful of what letter you're going to put on the longest side. Okay? Like for example, let me try another letter. Let's try FGH. Okay? This would be F, G, then H. Okay? So you need to be aware of what you put here. Why? So now that I put H here as my longest side, it implies that your H is the longest side. And where does longest side should be located? It's always on the right side, or it's just being alone on the equation. In other words, it would look like this way. F squared plus G squared is equal to H squared. That's it. Okay? But what if we change it? Like, let's just say we have G squared is the longest side, or sorry, G as the longest side and H as the base. It will differ though. What we'll have is we will have F squared plus H squared is equal to G squared. You see the difference? So in terms of the sides, you can rearrange them as long as they are adding, like you're going to add them. But here, whatever letter or variable that you're going to represent the longest side shall be left alone. Okay? Just like this one, since your g is on the longest side, so you will have g squared alone. Okay? So let's have some, let's have some, how should I say this? What's that again? Let's just say examples. Much better. Yeah. Examples. This is actually the common example of solving a right triangle with Pythagorean theorem. If I have a side of 3 here and a base of 4, what will be my longest side? So here, I can let my A as 3 and B as 4. Then my C as the longest side. So I will have A squared plus B squared is equal to C squared. So your A here, it's 3 plus my B is 4. Okay? Then C squared. Okay? So here, 3 squared is 9, 4 squared is 16, and we have C squared. Now, you will have a total sum of 25. Now, let's find your C. So, to find your C, you will square root both sides, and we will have 5 as your C. Therefore, this is 5. Okay? By the way, you can, what do you call this one? Right? I substitute A as 3 and B as 4. You can change that actually. You can have A as your 4 and you can have B as your 3. Okay? You can do that. All right? But the longest side, however, shall not be changed. Okay? So let me give you one more example. Okay. Actually, guys, this is basic. I think it's been taught like, I think when you were like in a middle school or junior high school. But anyways, let's just proceed. Okay? Suppose you have 14 units. Okay? Then here you have 20 units. So what will be the missing side? Try it. You can pause this video if you like to. Okay, so pick which one would be your A, which one would be your B. Okay? So your A is your 14. Then your B is your 20. Then your C is missing. Okay? So you will have A squared plus B squared is equal to C squared. So here you will have 14 squared plus 20 squared is equal to the square of C or C squared. 14 squared, let me just use my calculator. Forgive me. It's 196. Okay, 196. 2 squared, 20 squared is 400. Am I right? I don't want to jump to conclusion, so just in case. So 400. Then is equal to C squared. So add them, you will have 596. Okay. Now let's find your C by square rooting both sides. So the square root of 596 is just, yeah, it's just the same. 596 is equal to C. Or we can simplify this one because you see, uh, we can have what do you call this one? We can have 590 596 as 4 times 100 then no wait 149 because 4 times 149 is equal to 596. And you see in if you learned before like in algebra that in a square root or in any root, let's just say n root of n times m, we can separate them. So we will have n root of n times n root of m. You get me? So with that, we can have square root of 4 times square root of 149 is equal to c. So square root of 4 is 2. Then times this one, so you will have the square root of 149 is equal to c. Or if you're going to approximate that value in two decimal places, so you will have 24.41 units. Okay? So that will be the length here. All right? So one more example though. Wait, why am I using this one? So one more example. Okay. Remember, the formula of the Pythagorean theorem, commonly it's a squared plus b squared is equal to c squared, where your c is the longest side. Okay? And we can use any letters just like just like what I did earlier. So it's up to you. Okay? So I think you get my point, all right? Like, for example, if I have Z here, then you have A, B. So that means your Z here is the longest side. So you will have A squared plus B squared is equal to Z squared. Now, let's have, the example. Let's just say your longest side is, hmm, let's just say it's 10. All right, let's just say it's 10. Then here, uh, this is 8 and this is 6. Okay? Oh wait, oh my God, what? Okay, anyways. So here, in this problem, can you prove that they are a right triangle? I mean, this triangle is a right triangle when you have this side. Can you prove it? Okay. Like, can you prove that with these given sides in this triangle, this is actually a right triangle? Can you prove that? We can prove that this is a right triangle by using Pythagorean theorem. Okay, so a squared plus b squared is equal to c squared. So pick which one is your a, which one is your b. So my a would be 6, my b would be 8. My c is the longest, so it is 10. So let's take a look. 6 squared is 36, and 8 squared is 64, and 10 squared is 100. Add 36 and 64 together, you will have 100. So as you can see, both of them are equal to each other. I mean, both sides are equal to each other. That means it implies that this is a right triangle. Okay, this is a right triangle. Okay, once again, this is a right triangle. Okay, so we can use this theorem to prove if the triangle itself is right. Okay, so let's have another one. Okay, let's just say that, wait, let me erase this one. I have the given sides. We have, let's just say 13. This one is 17. And this one is 20. Do you think this is a right triangle? Let's take a look. Okay. So I will let A be 13 and B as 17. We already know your C because your C is the longest side. So this would be, A squared plus B squared is equal to C squared. Okay, wait for a moment. Let me just, alright. So your A here is 13, your B here is 17, and your C is 20. So now let's, simplify. 13 squared is 169, 17 squared, let me just use my calculator for a second. That would be 289 is equal to the square of 20, 400. Now add them together. 169 plus 289, you will have 458 units, which is not equal to 400 units. In fact, this is actually greater than 400 units. So therefore, this is not a right triangle. Okay? So you see the two examples that I gave right now, these are basically, can you prove that the triangle itself is a right triangle when you have when you have those given sides? So we can use Pythagorean theorem to prove that the triangle is a right triangle by using that formula. All right, so that's basically how you will use Pythagorean theorem to prove if the triangle itself is a right triangle. All right. Otherwise, that will not be a right triangle anymore. So why did I include this one as one of the examples? Because sometimes you see, right, a right triangle should have a 90-degree, right? Sometimes they are not present. So just in case, we need to know if it's a right triangle or not. Okay? So there we go. That's basically it. All right. Actually, let's have two more examples. All right. And these two examples are basically, how should I say this? They are basically real life problems. Right. You know what? Let me just enlarge this for a second. Wait, let me just enlarge this one. Okay. For a while, forgive me. Let me just enlarge them into 18. Wait, all of them should be 18. 18. Okay. There you go. So let me just have some space here and yay, there we go. So suppose you have two friends, Clark and Liza. They will jog on their own direction. Liza heads eastward while Clark heads north, or actually heads east. Uh, Grammar, forgive me. So the total distances they travel are 3 meters for Liza and 6 meters for Clark. What is the distance between the two of them when they achieve their total distance? Right? When they achieve their total distance. Okay? So imagine that this is their starting point. Right? They're going to jog. According to them, they'll jog on their own direction. Liza heads east. So it goes east. Then for Clark, he goes north. Okay? Clark goes north. Now, our goal is to actually find the distance between the two of them. Okay? Like, wait. Right? This is their total distance, right? So, what would be their total distance? So, here we're going to apply Pythagorean theorem. Okay? I already explained this to you already. Liza heads east, so this is actually 3 meters. Clark heads north, a total of 6 meters, right? Now, what will be the distance between the two of them when they achieve their total distance? Okay, so here we're going to apply Pythagorean theorem. So you can use A, B, C, whatsoever, or any letters. For me, I would like to use C as for the Clark, okay, C for 6 meters, and L for 3 meters. Then let's just say the question mark, the longest side, by the way, I will represent this as H, much better. Or you know what? D. D. Okay? So now that I represent D as the longest side, what will be the formula? You will have C squared plus L squared is equal to B squared. Okay? So your C here is 6 meters. Okay? So 6 meters squared plus 3 meters squared is equal to D squared. So this is 36 meters squared plus 3 squared, which is 9 meters squared, is equal to D squared. 36 plus 9, you will have 45 meters squared. Am I right? 36 plus 9. Here we go again. 36 plus 9 is 45. Yeah, there we go. Okay, so it's equal to D squared. So let's find now your D. So you're going to square root both sides. You will have the square root of 45 meters is equal to D. Or we can simplify this one because you see 45 is just the same as 9 times 5. Okay? And as like what I told you earlier, we can separate these two bases with their own root. Hence, we have square root of 9 times square root of 5 meters is equal to D. Square root of 9 is 3. So you have 3 times square root of 5 meters. Exactly. Or we can approximate this one so that we can know the value of it, at least by estimates. So let's just say we approximate that answer into two decimal places. You will have 6.71 meters. So that's how far they are to each other when they achieve their total distances. Yeah, their total distance. Okay? So that will be it. All right? So it's okay if you're going to use this one as your A, this one as your B, then the longest side will be your C. It's up to you. It's okay. All right. As long as make sure that the whatever variable you put on the longest side, that will be left alone. Just like this one, D, I use it to represent the distance between Clark and Liza, which is the longest side, by the way. So it shall be left alone here. Okay? Now let's try to answer one problem. There are two cars traveling at their own direction. Car A travels south while car B travels west. After 1 minute, the distance between the two of them is 350 meters, and the total distance traveled by car A is 100 meters. What will be the total distance of car B when it reaches 1 minute? So let's visualize. So here, let me just draw here. Car A travels south, so it goes south. Okay? And car B travels west, so it's here. All right? So here, you see, after 1 minute, the distance between the two of them, which is this, by the way. Wait, this is car A, this is car B. After 1 minute, the distance between the two of them is 350 meters. Okay? And the total distance traveled by car is 100 meters. So what will be the total distance of car B when it reaches 1 minute? Okay? So here, you see, the distance between the two of them, which is B and A, is the longest side, 350 meters. Okay? And your A is 100 meters. So how about your B? Right? So, okay, we have A as our 100 meters. Your B is missing. And your C is given, which is the longest side, by the way. It's 350 meters. So the formula would be, of course, A squared, B squared is equal to C squared. Substitute, your A is 100 meters squared plus B squared, which is the missing one, then C squared, which is 350 meters squared. So let's find your B. So this one is easy, just basically some algebraic transformation, like make B alone here so that you can find the what do you call this one? So you can find the value of it, and that's it. Okay, just like for example, x plus y is equal to z. How to find your y? Make y alone. So transpose x outside, from the to the right side, you will have y is equal to z minus x. So there you go, right? So that's it. So here, what I can do first is I will expand them. So the square of 100, I do believe it's 10,000. 10,000 or 1,000, I do believe. Wait. Is it 100 square? Yeah, 10,000 meters squared or square meters rather. Hold on. So square meters plus b squared is equal to the square of 350, which is 122,000 or 122,500 meters squared. So I'll transpose 10,000 meters squared so that I can find my b squared or so that I can find my b. So 122,500 meters squared minus 10,000 meters squared. Okay? So subtract them. You will have wait. Wait. For a while. 350 squared is, yeah, 122,500 meters squared. Okay, so minus 10,000. Okay. Okay. So here the answer would be 112,500 meters squared. Okay. So now let's find your B. So we're going to square root both sides. Your B would be, it actually doesn't tell though. what is the third form or exact value, but we can approximate this answer. Approximately, in two decimal place, this is actually 335.400 point 41 pala. Okay? So that's the answer. So that's it. Your B, or the total distance of car B when it reaches 1 minute is approximately 335.41. All right? So I think that will be all, guys. All right? So maybe next time we're going to have some, what do you call this one? Some practice. Okay, practice for Pythagorean theorem. Because after that, because yeah, after Pythagorean theorem, we're going to talk about the six trigonometric ratios, right? Which is basically the core functions of trigonometry. So that will be all. See you soon.